Hello and welcome to another session in this IBDP MAIHL course. And today we are going to talk about introduction to the integration, or you can say antiderivative of the functions of type ax raised to the power n plus bx to the power n minus 1 and so on. Remember, n is not equal to minus 1 for now. Okay. Now let me tell you something about the antiderivative or integration first, and later we will see there are techniques to integrate a function, how we can do that, what will happen if the terms are in multiplication, division, or there is some composition. So there are various approaches or various methods. For SL, we have only the antiderivative of these polynomial functions, right? But in HL part, we have lots of things to do. Okay. Now, we will also see using the technology how to find the area under the curve or what this integral means. Actually, we divide this integral into two parts, integration into two parts. One is indefinite integral, where we will get our answer in terms of a constant of integration. So, indefinite integral, and second one is definite integral, where we will get a definite answer using the limits. And the symbol is this integration f of x dx. It means we are integrating this function f of x with respect to x. Okay. For the definite integral, we will be having some limits. So here we have the lower limit, and here we have upper limit. Okay. In case of definite integral, we will have the limits. In case of indefinite integral, they will not give you limits, right? Okay. So first and most important thing is the process of finding y from dy over dx or the fx from the f prime x is called antiderivative. It means you have to use the process of derivative in the reverse order. Okay. So if you do remember a function whose derivative is known to you, you can easily calculate its integral, right? So for example, if we have a function, let's call f of x, okay, and if you differentiate that capital F of x, let's say you are getting fx, and now if you integrate this f of x with respect to x, then you will get your f of x, but this time you will get plus c. I'll show you why. See, if I say find the derivative of, let's say, x squared, okay, so we do know the derivative of x squared is 2x. Similarly, the derivative of x squared plus 1, what is that? That's also 2x. If we find the derivative of x squared plus 7, still it is 2x, because that constant number is not affecting that answer, right? So that's why in case of integral, you are not sure whether your answer is x squared or x squared plus 1 or x squared plus 7. So simply you can say if you have to integrate 2x, your answer will be x squared plus some constant. C is the constant of integration. Okay, so we are going to use these things. Now, let's solve some problem and see how can we integrate a function. Okay, so starting with this 9x squared plus 6x raised to the power negative 3. So first of all, for the functions of type integration x raised to the power n dx, the integral is given by, you have to think of a function whose derivative is known to you. So if you take x to the power n plus 1 over n plus 1, yes, if you differentiate it, you will get x to the power n from here, right? So add plus c to it, and remember, n must not be equal to negative 1. For all other values of n, you can use this, but if n is equal to minus 1, then you cannot apply this one. We have a different formula for that in terms of logarithms. Okay, let's apply it. 9x squared plus 6x raised to the negative 3 dx. So if we have to integrate it, let's distribute this integral sign using the linear property. So we have 9 times integration of x squared dx plus 6 times integration of x to the negative 3 dx. Now 9 as it is. For the x squared, use this. Okay, the power is not negative 1, so we can apply this. 9 times increase 1 power and divide by the same power. So 9 times x cubed by 3 for the first part plus 6 times, what is that? Increase 1 power. So x raised to the power negative 3 plus 1 makes it negative 2 divided by that power which is negative 2. Always add constant of integration plus c, and now if you simplify this part you will get your final answer, which comes out as, in this case, 3x squared minus 3x raised to the negative 2 plus c, and you can mention where c is constant of integration. That's your indefinite integral. Okay, next problem. It says integration of x to the power 5 minus 3 over 2x square. Now the thing is, can you integrate both numerator and denominator separately? No. We have different approaches here. Okay. So first of all, you need to split this denominator to each term in the numerator. For that, I'll get x to the power 5 whole divided by 2x squared minus 3 over 2x squared dx. Now we can integrate each term separately and we can get our answer. So first we have half of x raised to the power 3, and after that we have minus sign, 2/3 integration of what? X to the negative 2 dx. So negative 2 is okay, right? It's not negative 1, right? We can use the formula here. We will get half as it is. Increase 1 power of x, which makes it x to the power 4 divided by 4, minus 2/3 of x raised to the power what? Negative 1 whole divided by minus 1 plus c. Always add plus c to it, right? And hence my final answer is 1 by 8 x to the power 4 minus minus will become plus 2/3 of x raised to the negative 1 plus c. Okay, in this way you can integrate it. If they gives you other form or any other expression, then you have to think of a function whose derivative is known to you, or sometimes you have to simplify the given expression to get this standard form, right? Okay. Next one is this question. It says you have to find the expression. Okay. Find the value of the expression with the given boundary problems. So dy by dx is 4x plus 2. Let's write it. Dy over dx equals 4x plus 2. Also, our curve passes through a point 2 comma 3, because x is 2, then y is 3. So whatever be the value of y we get from here after integrating it, we can put x equals to 2, y equal to 3 to get the value of that unknown constant of integration. So this time we will get a particular equation of the curve. We also call it particular solution. Okay. So if I integrate it, what I will get? We have dy equals 4x plus 2 dx. Now, if I integrate it, on the left side, I'll get y equals, now for this side, I will have 4 times integration of x, which is x squared by 2 plus, now the integration of 2, what is that? 2x, correct? Integration of 1 is x, because the derivative of x is 1, plus c, where c is constant of integration. Now our curve passes through 2 comma 3. So from here I'm getting the value of y with constant of integration as 2x square plus 2x plus c. Now you can put x2 and y equals to 3 here to get the c value. So 3 equals 2 times 2 squared plus 2 times 2 plus c. So we will get c value from here comes out as this is 8 plus 4, 12 minus 3 gives 9, so negative 9. Okay, and therefore the equation of the curve is y equals 2x square plus 2x minus 9. That's the answer. Okay, next one. Now let's talk about that definite integral part. There is a fundamental theorem of calculus which says for a continuous function with antiderivative fx having the antiderivative capital Fx, then The definite integral of that will be given by integrate it in normal way, then put upper limit in place of x minus lower limit in place of x, and you can get your answer. Okay. All I'm saying is, let's say you have to integrate from 1 to 3 for the x squared dx. So what you can do is integrate this x squared normally, so which is x cubed over 3, right? That's your, this part is your f of x, and this x cubed by 3 is the capital Fx, plus c. If you want to add plus c, then it's okay, otherwise you don't need this because we have definite integral this time, so that will not affect your answer if even if you add that constant of integration. Now the limits part, lower limit is 1, upper limit is 3. So all you have to do is in place of x put upper limit, which gives you, in place of x I'm taking 3, so 3 cubed by 3, then a minus sign, then put the lower limit which is 1 cubed over 3. And on solving this we will get our answer, right? So in this way you can calculate the definite integral value. So f of x, integrate that, put upper limit minus lower limit gives me the definite integral value. Now what that definite integral represent? What's the geometrical meaning of that? Let's come to that. Basically, if you have a function which is continuous as well as positive function in this case, later we will develop methods to calculate the definite integral or area under the curve for any given curve, whether it is above the x-axis, below the x-axis, discontinuous, whatever it is. Okay, we have different methods for that. But for now, we are trying to understand what does definite integral means. Okay, so let's say you have a continuous function here which is positive also in the interval a to b. Okay, now the area under the curve between x equal to a to x equal to b of that f of x with x-axis is given by integration lower limit to upper limit f of x dx. That's the answer. Okay, it means this is the curve y equal to f of x, then the area between x equal to a to x equal to b made with x-axis is given by integrating that function f of x. You have to find the value of y in terms of x dx with limits a to b. And once you calculate it, you can also use your GDC for doing that. Okay, you can go to menu, then in the calculus you can find the numerical integral. Here you can enter the lower limit, upper limit and your function value to integrate the function. Okay, now let's solve a question based on this information. So problem says we are looking for the area enclosed by y equal to 2x cubed minus 1 with the x-axis between the lines x equal to 2 to x equals to 3. So it's, what's the definite integral representation for this? Integration, first you have to find the value of y in terms of x. So what is that? 2x cube minus 1. That's your fx part dx. Now the lower limit is 2 to 3. Now if you want it, you can integrate this function, put upper limit in place of x, minus sign, lower limit in place of x, you can get your answer. That's first approach. So you can do it manually. Otherwise, you can use your calculator also to get the answer, which gives me directly 31.5. For MAIHL course, they want you to find the value of these definite integral using the technology. Okay. And one more thing, if they, instead of this expression, if they say is like the equation of the curve is y squared is equal to 5x minus 7 or something like this. So in these cases, first you need to find the value of y in terms of x. So you cannot enter this 5x minus 7 as your fx here. No, that's not fx. You have to find the value of y that comes out as square root of 5x minus 7. Plus minus are there. This time if there is a symmetry or depending on the problem, we can take plus or minus sign accordingly. But yes, this is going to be our f of x part. Okay. So is it clear to you? Like the expression will be given to you. You have to find the value of y from that expression in terms of x to get the fx value, and then integrate it with the given limits. to get the area under the curve for that equation of the curve with x-axis from x equal to a to x equal to b. Okay, so that's it for this session, and now we have covered these, how to integrate the function, right, where n is not equal to -1. Rearranging the term means first you need to simplify the expression, convert it in that standard form, and then only you can integrate it. Using the technology, evaluating the integrals of the form means finding the area under the curve, and also find the expression for the y with the given dy over dx value. It means finding that constant of integration value with the given information. So that's it for today. See you in the next part. Keep watching, keep learning.